Questions 21 through 25 on the 2016 Grade 7 Gauss Math Contest. A 10 by 10 grid is created using 100 points as shown. Point P is given. One of the other 99 points is randomly chosen to be Q. What is the probability that the line segment PQ is vertical or horizontal? Well, if we want it to be horizontal, that line segment, then Q obviously has to go here, one of those dots. That's the only way that PQ will be horizontal. So for example, if we chose this guy to be Q, then the line would be horizontal. So how many dots are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So nine places where you can put the Q to make PQ horizontal. Now let's take a look at vertical. Vertical, of course, going top to bottom like that. If any of those are chosen to be Q, for example, if this one is Q, then PQ would be vertical. Well, how many of those are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's 9 there as well. Okay. So 9 and 9, that's 18. So 18 of those 99 dots can be chosen to make PQ vertical or horizontal. So that's the probability. And they'll probably reduce this. So divide top and bottom by 9 and you get 2 over 11, which is choice A. The 8 vertices of a cube are randomly labeled with the integers 1 through 8 inclusive. Judith looks at the labels of the 4 vertices of one of the faces of the cube. She lists these 4 labels in increasing order. After doing this for all 6 faces, she gets the following 6 lists right here. The label of the vertex of the cube that is farthest away from the label 2, the vertex label 2, is. Okay, let's draw a cube and try to match all of this together. Okay, let's see if we can match this. They want us to figure out this guy right here. X, that's going to be the one furthest away from 2. Okay, so what I'm going to do is concentrate on just this 2 here. Let's just look at the ones that have a 2 in it. Those 3, right? So those 3, I'm going to try to place them. 1, 2, 5, 8. That's one face. And then what's the next one? 2, 4, 5, 7. And then 2, 3, 7, 8. Okay, so a little bit of trial and error. So let's start with this guy. 2, 3, 7, 8. So how can I place that? Well, we have to think about this because essentially, because 2 is common to all of these, they all have to match. So let's see here. I've noticed that the 8 belongs to another guy as well, another face. So if I put the 8 on one face, it's also got to match with another face. So the 3 faces, first of all, that the 2 is involved with is that one, this one, and of course this one. So the 2 is common to all 3 faces, but the 8 is common to 2 of them. Okay, so I'm going to put the 8 here because that way it would be part of that face, but it would also be part of this face. Okay, so far so good. Now, the 2, 3, 7, 8, I've got to put the 3 somewhere and the 7 somewhere. So I got 50-50 odds here. So let's try a 3 here, a 7 here, and a 3 there. If I'm wrong, I can flip them. Okay, so I think I'm okay with this one. Okay, now let's try this one since it has the 8 in it. The 2 and the 8 are already there, so I got to put the 1 and the 5 somewhere. Now, one thing is for sure is that the 5 is common to the other one as well. So this face and this face both have to have a 5 in it. So that means the 5 must go here. And then by process of elimination, the 1 goes there. And then I can now put this guy, 2, 4, 5, 7. 2, 4, 5, 7 for this face. And that means the 4's got to go there. So I figured it all out. If you didn't, no problem. You just do trial and error. You say, okay, this didn't work. Let me try something else. Now I can easily figure out X. I've used every number 1, 2, 3, 4, 5. I have not used 6, 7, and 8, so that means x must be a 6. And there you go, number 22. The answer is D. Angie has a jar that contains 2 red marbles, 2 blue marbles, and no other marbles. She randomly draws 2 marbles from the jar. If the marbles are the same color, she discards one and puts the other back into the jar. If the marbles are different colors, she discards the red marble and puts the blue marble back into the jar. She repeats this process a total of 3 times. What is the probability that the remaining marble is red? All right. So in the very beginning, we've got 2 red and we've got 2 blue. So we have 3 draws, right? 3 times. Okay, so draw 1, draw 2, and draw 3. So let's see what happens. So the first draw, if we are going to choose 2 randomly from these 4, the possible outcomes, you can have either 2 red, 2 blue, or a red and a blue. So those are the only 3 possible outcomes if you choose 2 at random from these 4. All right, so either 2 red, 2 blue, or 1 red, 1 blue. Now, if this is the outcome, according to the question, because they're the same color, she will discard 1 and put 1 back into the jar. So 1 she will throw away, and then she'll put the other one back into the jar. So the jar will then become RBB, right? Because initially, when you took these out, you just had 2 B's left, and now you're putting 1 red back. Similarly, with this guy, it would also be RBB for pretty much the same reason. And then this one, it's different. Here, she discards the red marble and puts the blue back. So then my jar would basically be RB plus B, so RBB, like this. Okay, so draw number 1 is complete. Now, from our jars that have 3 possible, outcomes, we have to now draw 2 again. So when we draw 2, we have either R and B or BB. Those are the only 2 possible outcomes. There's no RR outcome because there's only 1 R. Similarly, from this jar, RB and BB are the only outcomes, and similarly the same holds true here, RB and BB. So this is what the possibilities are for draw number 2. And then when you draw these, again, we have to now see what will the jar look like. Well, same story. You would discard the red, add the blue back, so the jar would now become BB. And the same kind of thing here, because there's 2, you discard 1 and put the other one back, so the jar would now become RB. And so on, you do the whole thing, BB, RB, RB, and RB. Now, finally, we get to the draw number 3. Well, draw number 3 is pretty straightforward. There's only 2 in the jar, so when you draw 2, you're basically just drawing those 2. And then, because you're only drawing those 2, those are the only things that would ever show up. So the draw 2 is pretty straightforward. For each of these, there's only one possible outcome for the draw, and that is the 2 marbles that are in the jar. Now we have to figure out what happens here. What does the jar look like based on our rules? Well, because these are the same color, you discard 1 and keep the other. Here, they're different colors, so you discard only the red, keep the blue. Same color, discard 1, keep the other. Here, you discard the red, keep the blue. Discard the red, keep the blue. Discard the red, keep the blue. Now, these represent, this row here represents the final outcome, the very last remaining marble. And they're saying, what is the probability that that remaining marble is red? Well, as you can see, they're all blue. So if you do this process, you never get a red. So the probability of getting a red is 0. So number 23, the answer is E. How many of the 5 numbers 101, 148, 200, 512, and 621 cannot be expressed as the sum of 2 or more consecutive positive integers? Well, 2 consecutive positive integers are x plus 1, which is 2x plus 1. 3 consecutive positive integers are x plus 1 plus x plus 2, which is 3x plus 3, and so on, right? You get the idea. And similarly, you can get 4x plus 6, 5x plus 10, and it just keeps on going. 6x plus 15, as far as you want to go. 7x plus 21, 8x plus 28, and so on and so forth. So let's see. Let's try this one at a time. 101, well, that's pretty straightforward. I think I can get that just by inspection. That's 50 plus 51. So this one definitely can be. 148, this is the one where you have to start looking deeper into these guys. And when you do, you find out that you get an integer solution when you set it equal to 8x plus 28. When you set it to 8x plus 28, x is equal to 15. So basically 148 is 15 plus 16 plus ... all the way till 22. All right, we got 148 to be expressed as the sum of consecutive positive integers. Let's try 200. 200, again, after you fiddle around with this, you'll see that there's a solution for 5x plus 10. X will be 38. So 200 is equal to 38 plus 39 plus 40 plus 41 plus 42, like that. So 200 can be written as the sum of consecutive integers. Let's try 621. So I'm going to skip over 512 for a little bit. 621, again, when you fiddle around very quickly, the good news is you figure out that you get a solution for just 2x plus 1. X is 310. So 621 is very easily written as the sum of just 2 consecutive numbers, 310 plus 311. Okay. So now, there's only one left. So you got a choice. Is 512 possible to write as consecutive integers or no? Well, we've already eliminated E, D, and C. If 512 can be written as consecutive integers, the answer to this question would be A. If it cannot, then the answer to this question would be B. Well, that's our task now. 512 is the big one. That's the most challenging one. And there's a couple of different approaches. The first approach is, of course, exhausting yourself with this and going on forever. And it's very time consuming. The other way is to see, can it be broken up into consecutive integers, but you break it up into 2 categories: an even number of integers and an odd number of integers. So for example, if it was an odd number of consecutive numbers, like for example 6, 7, 8, 9, and 10, that's an odd number, right? 5, 1, 2, 3, 4, 5. An odd number of consecutive integers. If that was the way 512 is broken down, then basically what that would mean is that you could write 512 as a product of the middle number times how many numbers you have. So in this case, it would be 8 times 5, where 8 is the middle number and P is the number of numbers. So I'll write M as the middle number and P represents how many of those numbers we have. So if this was the case, 512 could be written as MP. And if you recall, in this example, we had 5 numbers. So P in this case was 5, and M in this case, the middle number was 8. Well, we are saying that P is odd. So can m times p be equal to 512? No, because if p is odd, 512 divided by p would not give you an integer. M has to be an integer. 512 can only be divided by even numbers, 2, 4, 8, so on. So that shows this is not possible. So the only other thing that could be the case is that 512 is written as the sum of consecutive integers where the number of integers is even. So for example, like 6, 7, 8, 9, 10, 11, right? That's what? 1, 2, 3, 4, 6 integers. So in this case, we have 6 integers, and in this particular example, p is 6. And in the middle number, well, there is no middle number, but there are two numbers. There's m and m plus 1. We can call this guy m, and we can call this guy m plus 1. So what you would do is you would take the average of that, m plus 1, divided by 2, and you multiply that by p. So in this particular case, it would be what? 8.5 times 6. Which is 51, right? The sum of these guys. So let's do the same thing with 512. It's basically going to be m plus 1 divided by 2 times p. So 512 is going to be, what's that? M plus a half times p. And remember, p is even. Well, immediately this looks kind of weird. How can you have a half in there? So to avoid confusion, I'm going to multiply through by 2. That might make things a little better. That would become 2m plus 1 times p. Well, now again, remember p, in this case, we have set it to be even, just how p was 6 here, an even number. So 1024 divided by p, which is an even number, has got to be 2m plus 1. Well, 2m plus 1, that is an odd number. That form, 2m plus 1, is odd. So 1024 divided by some even number has got to equal an odd number. Or another way of analyzing this is that 1024 divided by 2m plus 1 is equal to p. So 1024 divided by some odd number is equal to an even number. But neither of these scenarios works, because 1024 does not have any odd divisors. It only has even divisors. It's essentially just 2 to the power of 10, I believe. So there you go, in a very even way, or not even way, in a very thorough way, we are able to show that 512 is not possibly written by in consecutive numbers. So you have a choice. Either you can do it in that sort of scientific way, or you can just do it in the more exhaustive way, but that's really time consuming. So we have shown that 512 cannot be written as the sum of consecutive positive integers, so therefore one of these is the answer. So number 24, the answer is B. In the triangle shown, the first diagonal line, 1, 2, 3, 4, begins at 1, and each number after the first is 1 larger than the previous number. The second diagonal line, 2, 4, 6, 8, begins at 2, and each number after the first is 2 larger than the previous number. The nth diagonal line begins at n, and each number after the first is n larger than the previous number. In which horizontal row does the number 2016 first appear? All right. Let's discuss this a little bit. Let's say I said to you that I want you to tell me, when does the first 10 appear? Well, the first 10 obviously appears here. I mean, how could you figure that out, though? Well, it appears in this diagonal. So you can say, well, the diagonal starts with 2. So 10 is a number that I'm interested in. I'll divide by 2, and that's 5. So it appears here, the fifth entry in that diagonal. But that's not the row number. As you can see, it's in the 6th row. And how do you get the 6th row? Well, you take that 5 and you add to it this number minus 1. So 2 minus 1. And that would give you the 6th row. Very similarly, if I said to you, when does the first 12 appear? Okay, well, it appears obviously in that diagonal. So that diagonal begins with a 3. So you take the number 12, divide by 3, and that's the 4th entry in that row. But it's not the 4th row, it's actually in the 6th row. How do you get the 6th row? Well, you take this 4 and add to it 3 minus 1. And that would give you 6. So in a very similar way, we have to do that, but this time our number is 2016. So this is the table. We first have to figure out the factor of 2016. So this is factor of 2016. And that represents n, which will be the same n as what they talk about in the question. So for example, if n was 4, it would be this diagonal. If n was 5, it would be this diagonal, and so on. The next column in this table is the position in the diagonal. So for example, if I said to you, what position is that in this diagonal? Well, it's the 4th position, right? 1, 2, 3, 4. If I said to you, what position is this in the second diagonal? Well, it's the 1, 2, 3, 4, 5th position. So I will call that D. And then finally, we have to figure out the row. And the row is given by D plus n minus 1, exactly what I did over here. So a quick example, we'll just start with 2016, and I guess those will be good enough examples. There's a lot of factors, right? 2016, if you break it up into its prime factors, is 2 to the power of 5 times 3 to the power of 2 times 7 to the power of 1. So as you can see, there's a lot of factors. That's a 6. The way you do it is you take the number 5, you add 1, they take this 2, add 1, then you take that 1 and you add 1, and that multiplied together gives you the number of factors. 6 times 3 times 2 is 36. So there's 36 factors. So got a little bit of work on our hands, but it's okay. Let's start. 1, 2, 3. These are the factors of 2016. 1, 2, 3, 4, 6, 7, 8, 9, 12. 14, 16, 18, 21, 24, 28, 32, 36, 42, 48. And we keep on going here. 56, 63, 72, 84, 96, 112, 144, 168, 224, and so on. And if we need to go further, we will, but I think we should be able to figure out a pattern. At least I hope so. Okay, so let's go to this table. When an n is 1, the position in the nth row is 2016 divided by n. That's how you would get it. So I'm going to actually write that in red, because 2016 divided by n is how we're going to get D. Well, in this case, it's pretty straightforward. That's just 2016. Okay, now the next one is D plus n minus 1. So this is my D, this is my n, so that's just going to be 2016. Let's do the next one. 2016 this time divided by 2 is 1008. Now my row R would be D, which is 1008, plus n minus 1, which is 2 minus 1, which is 1, so that would be 1009. Now our goal is to get this number to be as low as possible. So let me put that in red. Lowest. The lowest possible number for this column of the table. That's going to be the answer to the question. So you just keep doing this. For 3, it'd be 2016 divided by 3, which is 672. And then the row would be 672 plus n minus 1. N is 3, so that would be plus 2, which is 674. So Now that you are an expert, I don't need to walk you through it. I'll just fill it out. 504, 507. And let's just see what the answer choices are. Oh, they're in the less than 100, so we got to keep going here. 336, 341, 288, 294, 252, 259, 224, 232, 168, 179, 144, 157. Okay, the numbers are getting smaller, so that's good. 126, 111, 112, and 129. Sorry, that was 141. 112 is 129. And then 96, 116, 84, 107, 72, 99. Is 99 one of the answer choices? Nope. Okay, no problem. We're getting close though. 63, 94. That is one of the answer choices. 56, 91, 48, and 89. And then 42, again 89. And then 36 and 91. Aha, it goes back up now. And I have a feeling it's going to go back up again. So 32, 94, there we go, it does. 28, 99, 24, 107. Yeah, it's pretty much going up in the same way. If you notice, this is the same as that. 89, 91, 94. Yeah, okay. So that means we hit rock bottom here. 89. That's the lowest number in that column. So that's the answer to the question. Number 25, 89, that would be E.